Hello everyone, welcome back to my YouTube channel A for Analysis. Here we talk about different machine learning projects and how to solve them in Python. Today's case study is about detecting credit card fraud. So credit card fraud is basically a very important problem faced by all the banks, and that's why it's very important that we understand the problem and also find out ways how can we reduce this issue using machine learning. Let's first understand what credit card fraud is. So credit card fraud is basically a fraudulent transaction happening for any particular credit card. So how can the fraudulent transaction take place? It can be by manipulating the genuine cards, it can be by creating a counterfeit card, sometimes by using a card which is stolen or lost, sometimes via fraudulent telemarketing. People can collect the information, important information about a credit card, and they can use it fraudulently. So basically, whenever a fraudulent transaction like this takes place, it's not just the customer's loss, it's also the loss from the bank's perspective as well, because this kind of cases, when they are on the rise, customers will lose trust on the banks as well. So banks have to find a way to avoid these scenarios, to detect the fraudulent transactions beforehand so that they don't allow such transactions. So we have a data set from Kaggle and we are gonna go through it. First we will do exploratory data analysis, then we'll divide it into training and test data, and then we'll build some models and we'll try to tune the hyperparameters, and we'll try to see what kind of models we can get which will give us the best results. And of course we also have to do some model evaluation, because this is a very important scenario where we want to find out as much as much fraudulent transactions as possible. So we'll see when we start working on it what are the issues and how we can mitigate those issues. Let's move on to the code part. So here the entire problem has been implemented in Python. You can also do it in other programming language, but I will walk you through the code anyway so that you can implement in your own ways. So first and foremost, we will import the libraries. So that's the first part we do. We have imported all the libraries we need, all the modules. So here you can see we have kept few for cross-validation, then we have for scaling and power transformation, we have some for model building, data imbalance handling, model evaluation, and all this stuff. So basically, when I started the case study, I was not sure what kind of modules I'll use or what kind of things will be important, but as I went on and I realized, okay, this is required or that is required, I just kept on adding those things at the top of my code. So you don't have to start with this many modules. You can start with very few and then you can keep on adding as you go through the steps. So let's first check out the exploratory data analysis. So first I have checked the dataset, how it looks like. So basically you can see that here is a time feature and all the other features are looking like V1, V2, something is there with amount, and there is a class. So class is basically our target variable which has just two values. It's a labeled column. Basically it has just 0 and 1 value. 0 means non-fraudulent transaction and 1 means fraudulent transaction, and rest of the columns are basically independent columns or they are features. But one thing you can tell right off the bat, that none of these features have the meaningful names given. So basically this data set has already gone through some transformation. It's already PCA transformed, so we cannot see the exact values. This is also not given to us because of privacy issues, so we are gonna work with this transformed data instead of the original data. So we don't know which one is phone number or if there is something very private information given to us, because all the feature names have been taken away and this is also transformed data, so we are good to go from here. So first of all, since we don't have the names of the features, we cannot really check from that perspective, like what features are uh, related to what other features, but we'll try our best to make the most sense out of this. So first we check the head, I mean just first 5 rows, and then we are checking the info function, which basically gives you an idea about the missing values, if there are any, or what kind of data types are available in the entire data frame. So as you can see, all of these are float 64 except the last one, which is class. It is integer. Next, it is very important to keep some comments when you are writing some code so that it becomes super easy for whoever is reviewing your code or whoever has to use your code. So here are the comments from my observations from the above 2 things. Next, we are checking, since we are dealing with labeled target column here, so it is very important for us to know whether the data is balanced or imbalanced. So here I am checking the counts of the class. Here is the non-fraudulent versus fraudulent transaction numbers. As you can see, the non-fraudulent numbers are very high, and you can see the percentage as well. So percentage I have printed here separately. So 99.827% of the data which is given to us is of non-fraudulent transactions, and there is very small number of cases, which is 0.173% of the data is of fraudulent cases. So basically this is what happens in real life. Like, we don't have so many fraudulent cases, but whenever they happen, they are a huge loss for both customer and for banks. So even though the number looks very small right at this time, but it's nevertheless very important to prevent these fraudulent transactions. So what we understand from this data set is hugely imbalanced, and that might be a problem for us when we try to feed this data to our machine learning model. So we'll come to that on a later stage. So for now, we just check whatever we can explore from this data. So we are checking on the time feature as well. This is one of the only features which have a meaningful name, given all the other features have v1, v2, and v3 and so on. So looks like the time feature doesn't have any meaningful trend for fraudulent and non-fraudulent. So we are gonna drop that feature. Next, we are checking on the distribution of amount, and again, it doesn't have any meaningful trend going on for fraudulent and non-fraudulent transactions, so probably we would drop this feature as well. Next, we are splitting the data into train and test set, because we should have some unseen data to check our model's performance, and we can never rely on the performance of the model on training data, because it has already seen the training data, is trained on the data. So we have to use something which is not seen to the model already. That's why we are keeping the test data separately. So next thing, we would check for the feature scaling, but feature scaling would not be required in this case study, in particular because the features that are given to us is already applied PCA. So before, it's usually we do the scaling before applying PCA. So right now we are just assuming that scaling is already done. So we have done scaling only for the amount column because it hasn't gone through any scaling or PCA, so that's what we did here. Next, since we have so many numeric features, we are checking for the distributions. We have to check for the distributions to understand whether there are any outliers or whether there is any skewness in the data. So that's what we are checking for here. So here I have taken all the numeric features that we have. I'm checking all the distribution here, and as we thought, there is actually some skewness going on. So in order to get rid of the skewness in the data, basically we have to transform our input features. So here for this particular case study, it was power transformer which helped us to get rid of the skewness. So in different case studies, it can be something different, but for this particular case study, power transformer helped us. Next, once we have done the power transformation, we are checking the features again, and looks like now our data is more centered around 0. So the transformation worked really well in that case. Basically, we have to try many different transformation, and we have to see what transformation is giving us the data centered around 0. So I haven't showed all the other things that I have tried. I have kept only one which worked for me, so you can try other transformations as well. Next is model building and model evaluation. So since this case study basically requires you to try out many different models, many different parameters, and you have to do it over and over again unless you find really good values, really good evaluation metrics. So I have written some reusable code block which I would be using, and it would make my work so much easier. So I have written some reusable code for building model with cross validation and one for evaluating the model. So built model with CV is basically nothing but we would give it the estimator, basically whether it's a logistic regression or whether it's a random forest classifier, whether it's something else. We would also supply it with a list of parameters basically to do the hyperparameter tuning as well. Then we will have the train data and test data, because of course we want to see the model performance, right? So that's why we're supplying all the training and test data. And scoring is basically we are focused on ROC AUC score. Next is in the evaluate model, this is the sound of the night guard. Please excuse the sound. So for the evaluate model, we are gonna use the y true, which is a true value, y pred, which is the predicted value, and eval div is basically a data frame where we'll store all the evaluation metrics score for all the models that we are going to try, so that we have a place where all the models score are stored, and we can have a quick look and understand which model is performing better. And model name I have kept not specified or a default value, and for most of the places I will specify the model name so that we know which model we have tried and which value we got. So first thing, we tried logistic regression. As you can see here, I haven't done any other operation on the training data. We already saw that the data has some imbalance issue, but right now we haven't done anything for the data imbalance. So one more thing you must observe here, that we are doing cross validation, which means we will also need validation data. So since we have already divided the data in training and test set, we would divide the training data further into training and validation data. That's what I have done here. Here we have done that. Next, we are starting with the modeling part. First, I did with logistic regression, imbalanced data, and most of the things are repetitive here, so I would just describe what I have done in a very high level so that you guys can go through the code and you can do it by yourself, or sometimes you can come back to my code and take some reference if you need. So I would try a lot of different models, and first one is logistic regression with imbalanced data. So this is our eval_df, which I was talking about just a few minutes back. Model name, we have logistic on imbalanced, we have accuracy score, sensitivity score, F1 score, and ROC AOC score. But I am printing so many evaluation scores, but we would concentrate on few only, which I'll talk about later. So let's try with few different models like KNN, SVM, decision tree, random forest, XGBoost. So KNN we tried, and for KNN you guys already know that we should know the right value of n, or the right value of nearest neighbors, right? So which we try from elbow method basically, and with the help of elbow method we decide our value of n, and then we try to train our model and do some predictions. So basically here I have taken only few values of n. Here as you can see I have taken 5, 10, 15, 25 and 40. This is purely because of computational reasons, because this was taking a lot of time for me to train the model for each of the values of n. I was doing it in Google Colab, and it's a free version, and it was taking quite a while. So I just tried 5 values. If you have enough computational resources, you can definitely try many different values as well, but I'm just making it sure that you guys understand this is not a hard and fast rule. I just had to stick with it because of the problem with computational resource. So here for 15 we got the least error, that's why we went with 15. I mean, definitely we could have tried with so many different n values, but we could try with only 5, and among those 5, 15 gave us the best result, so we went ahead with 15, and we didn't do any other cross-validation just because it was taking so much time. Next, for SVM we couldn't try because of, again, lack of computational resource. We moved on to decision tree with imbalanced data, as you can see, and you can also see that how many models we are trying. We are storing the scores here, and you must also know that these scores are based on test data, so this is reliable information. We are directly getting the test scores, so you can decide your final model just by looking at the eval_df. So decision tree and random forest we tried with imbalanced data, and here are the results. XGBoost, here are the results, and for except from KNN we have tried the cross validations as well. As you can see, hyperparameter tuning is done. As you can see, I have given the parameters here, and that's what I am passing on to the build model with CV method that I have written. So model building, hyperparameter tuning, everything is happening just at once. Next, we are also checking out the important features of the best model to understand the dataset. So far we have seen that the data is very imbalanced, but we haven't done anything about the imbalance. So right now we will handle the data imbalance in many different ways, and we'll see whether it's improving the model performance. So for this particular case study, I have tried 3 different ways to handle the data imbalance. First one is random oversampling, second one is SMOT, and the third one is addressing. So let's check that out. Basically, the data will be different, but we will build the model in the same way. We'll train the model, evaluate the model in the same way. Just the data we are supplying for training will be different. So that's the only difference. First of all, we did with random oversampling. So X trained ROS and Y trained ROS means we are using random oversampling. And then the same thing we are doing with logistic regression. As you can see, we have done KNN. Again, KNN, we haven't tried so many hyperparameter tunings or other things because it was taking so much time. SVM, again, for the entire case study, we have just skipped SVM because of, already, lack of computational resources. We have tried decision tree classifier, random forest, XGBoost classifier. So already 10 models have been tried, and as you can see, there are the RUC-AUC scores, F1 scores, and sensitivity scores. So best model on random oversampled data. With respect to ROC-AUC score, we could see that XGBoost classifier performed best, which is, you can see that 0.99999. Basically, it's just 1. And with respect to the sensitivity score, logistic regression model performed best on random oversampled data, where you can see that sensitivity score is best for this. But right now we'll not decide the best model, we'll try few more other options. Next, we are moving on to another method of handling data imbalance, which is SMOT. So again, we have done the oversampling. We have applied the oversampling method, SMOT. So oversampling is nothing but basically, since we have very less representation of the fraudulent transactions, we are trying to generate some similar data of fraudulent transactions so that we have enough representation of the fraudulent class to train our model. Basically, since our model is seeing so less amount of fraudulent transactions, it's very difficult for it to understand and train well to detect the fraudulent transactions. And since fraudulent transactions are more important and they are less in number, it becomes more important just to generate cases for fraudulent transactions. So yeah, here we are applying oversampling method named as SMOT. Again, the same thing, we are trying logistic regression, KNN, decision tree, random forest classifier, XGBoost. So we are getting all the values here in this data frame, eval_df. Next, in the SMOT, we got the best ROC-AUC score for XGBoost again. So for the last one as well, XGBoost performed the best. And for sensitivity score, KNN looks like the best model. Next, we are also checking out the class distribution after applying the oversampling method. So last but not the least, we are going to try Anderson oversampling method. And as you can see that this is originally how it looked like. You cannot really see the fraudulent transactions here, and here you were seeing that these are the data points which have been created by the oversampling method. So next we are making the X-train and Y-train with Addison, and same thing we are gonna do here. Again, we'll try out all the models, we'll see the values, and then we'll decide which is the best model and which we should go for. So yeah, here is logistic regression model, KNN, decision tree, random forest. Again, these are the values I have selected, and I kept only few values here in the hyperparameter part because of time limit and resource limit. You can try as many as you want if you have the right resource in your hand. So as you can see, we have tried 20 different models with different kind of data, different kind of oversampling method, and here are the results in front of you. So we have few decisions to make. One is which oversampling method we should use, and the next is which classifier we should go for. So here, as you can see, these models have very good ROC AOC scores, all the models that we have tried, and similarly sensitivity scores are also pretty good. Now we should also inspect the precision and F1 score of class 1, that is fraudulent class. So basically, as of this point, it was just the average F1 score, but we should be more attentive towards the F1 score of class 1, which is fraudulent transactions, because that is more important class level for this case study. So let's check out these comments now. So model performance on validation data, random forest classifier Bismuth had ROC AUC score of 0.99975 and sensitivity or recall for class equal to 1, which is our fraudulent transaction case, were very good as well, 0.86. However, the precision is very poor for class equal to 1. So precision is basically true positive by true positive plus false positive, which means out of all the positively predicted values, or out of all the values which have been predicted as positive or predicted as fraudulent by our model, how many are truly positive or how many are actually fraudulent transactions. So if I put it in a different way, out of all the cases, out of all the transactions which have been predicted as fraudulent transactions by our model, how many or how much percentage is originally fraudulent transactions? And as you can see, the precision rate is not very good, it's 58%. So out of 100 fraudulent transactions predicted by our machine learning model, only 58% are actually fraudulent. So we are basically predicting some genuine transactions as fraudulent transaction. So that's not a very good sign, because in those cases, if we cancel those transactions and those were genuine transactions, it will create some discomfort for the customers, and it will not be a good look for the bank as well. So we cannot go for such a poor precision rate. Now let's also check the fraudulent transactions average amount is 122 unit. I mean, is that something important we should know? Okay, so amount, if we think that it's in dollar, or if it is in we don't know which currency it is, but 122 unit doesn't look like very high. So amount is basically how much amount was taken from the account basically. So it doesn't look very high, so we can say that for the data we have at our hand, it doesn't have so many fraudulent cases where high amount of amount have been taken from the account. So we can say that basically it's very low amount which have been taken by the fraudulent cases. So one other thing we can say that XGBoost classifier with SMOT and Adacin has very good ROC ABC score. So probably we'll go with XGBoost. Let's see. And for SMOT, it had recall of 0.86 and precision 0.78. And for XGBoost with Adacin, we had recall of 0.85, which is almost similar as before, and precision of 0.78 on class 1. So here, precision we are more concerned about for only fraudulent transactions. And precision looks quite good here. So out of 100 fraudulent cases, as predicted by our model, 78 cases are predicted correctly. So we are not, so the manual labor is also decreased in that case, because as many fraudulent cases will be detected by the machine, there has to be a human verifier, or some way they will make sure that those cases are fraudulent or those cases are not. So since our precision is higher in this case, we will not have so much manual labor, and basically our model is better in this case. Since we are getting a very good recall, basically recall is same as sensitivity score, basically how many fraudulent transactions we are able to detect correctly, that is the sensitivity or recall. So this seems to be the right metrics, and along with that we are also looking at precision, which is equally important, because if it has a very low precision, means we will detect a lot of fraudulent transactions, but along with that we are also detecting a lot of genuine transactions as fraudulent transactions, and that will incur a lot of human labor to like go and check out whether they were actually fraudulent or not. So we don't want to have such a scenario. So lastly, we are just taking the best model here, selecting XGBoost classifier because of course it got the best ROCA score. Also recall and precision score were very good. Hyperparameters, learning rate 0.3, max depth 10, and n estimators equal to 100 gets the best results. Of course, I couldn't try a lot of hyperparameters, but if you try different values, probably you may get some other values in that case. Next, I'm trying to print the important features. Basically, here we cannot really understand the meaning since we are not given the features in their right names or in their right values, but we can nevertheless show the results to our clients so that whenever because they have the information, right? They have the feature names with them. So if we give us, like, say for example, V13 or V14 is the top variable, is the most important feature, they can go back and whatever the feature is, they can go back and they can use it in their own way. So yeah, we are just checking out the ROCA score, and this is the summary. So for limitation of computational resource, which I am telling for the 100th time in this video, we couldn't do all sorts of cross-validation and hyperparameter tuning. We just tried few ways only, and we also couldn't try the SVM method as well, SVM classifier as well. In case of banks with smaller average transactions, a high precision score is desired as we want to label only relevant transactions as fraudulent. So for every transaction that is flagged as fraudulent, an extra factor of human verification is added, and hence the bank would not want a lot of unnecessary human effort or misclassified non-fraudulent transactions. So this seems to be a case for us because we saw that average amount for the fraudulent transactions is 122 unit. I hope it's not 122K, $122,000 or 122 something else. It's not a higher. If it is in original scale given to us, then I think 122 is very less. So in that case, we would think that in this particular scenario, the bank is having smaller average transaction amount for fraudulent cases. In case of the banks with larger average transaction amount, the banks should focus more on the recall or sensitivity score. So sensitivity score is the primary metrics which we focused on for our best model. So our final model has a very good recall rate actually. As you can see, ROC AUC score and sensitivity scores are very good for the fraudulent transactions, and optimal hyperparameters are given as shown here. So yeah, that's for the case study, guys. I hope it was helpful for you. Please do give it a like if you found this helpful, and comment if you have any other questions. I would love to answer any of your doubts. Goodbye.